My name is Payal Godhani. I'm from Oracle Cloud Infrastructure. I work for a deployment service, and the topic for today is Mission Abort, intercepting dangerous deletes before Helm hits apply. This topic and this talk is going to focus on how we can safeguard our Kubernetes resources using a framework and prevent any 7 or Sev 2 incidents in production. So at least for Oracle, our cloud regions are expanding rapidly. We are growing at a very rapid pace. We have more than 100 plus regions going on, and we are going to add 50 more regions this year. So one of the difficulties that SREs has been facing is they are deploying 100 plus releases on an everyday basis because they have a huge ground to cover. They have so many cloud regions to deploy to, and along with the speed comes the trouble that there is a huge gap over there. So it becomes error prone. One of the incidents that come to my mind is there was one particular incident where the SREs did as they were expected to do the routine deployments, but what ended up happening was ended up deleting 18 load balancers in one go. And it was for one of our multi-million-dollar customers, so you can understand the impact and the severity of this incident. And as a result of it, we had a lot of 7 calls going on, and we were trying to figure out how to resolve this, what went wrong, because when the Helm deployment went through, it was successful. So let's take a look at what happened during that time. When the SRE was trying to deploy that Helm release, during the deployment planning, there were no warnings, no alarms that went off. When the deployment got executed, it marked as successful, nothing went wrong, everything worked as it was supposed to. But soon after, the alarm started firing up, the canaries turned green, canaries turned red, and yes, then obviously those gruesome calls on what went wrong, how did it go wrong. For the record, it took us 8+ hours to get that service back up and running. And obviously the multiple kappas and everything comes along with it. So then in this particular case, it was after a lot of debug, we got to know that there was just one condition that got flipped in one of the Helm charts, due to which those 18 load balancers were wiped off completely. Just a single small mistake, but to get to this level of debug and analysis, it took us so long. So then a very important question came to our mind, that is there something that we could do to make SRE's life easier, or the deployment executor who is going to execute this deployment, right? Obviously, the business impact that came along with it was, you guys can imagine how difficult it would be. In this case, it was load balancer. There have been multiple such 7 incidents where there were gateways also who got vanished. It resulted into service downtime. The customers are not able to reach to this service. Okay, sorry. And there have been times when there is data loss as well. There are important persistent volumes. Who hold the sensitive data were erased. The namespaces were deleted silently with no warning whatsoever, causing this huge business impact. And also, there is customer trust erosion that comes along with it. For us as Oracle Cloud, as a cloud provider, also could we have done something better for our customers? Also, they have to face those issues with their customers. And the operational overhead that also comes along with it on the post-mortem that you have to do along with it, all the debug calls, those 8 are knock calls where we have to sit and work through the debug and get the service up and running. So is there something we could do better in this case? So let's go through first few scenarios on why this could be happening. So with Helm charts, if anyone has used it, Helm works with the resources. So if there is any small resource renaming that happens within the Helm chart, Helm associates it as a new resource. It's a little declarative in nature. So it thinks of it as this is an old resource is getting deleted and a new resource is getting added. So that is one of the reasons. Other is the conditional logic one that we just saw earlier. One flip of a condition and you can end up in a 7/7 sort of a scenario. Then there are a lot of times organizations try to do this chart refactoring where they try to break a Helm chart into small subcharts, and the resources are moved around within the modules, but then it sometimes confuses Helm's resource ownership and relationship, due to which it also lands up in deleting few of the resources. And obviously the last one is the human error, where someone is trying to modify a YAML file and few of those excerpts in the YAMLs are getting deleted or getting commented out on a very ad hoc basis. So let's understand. In this case, if you ask this question, did Helm do something wrong? But Helm leans more on the declarative side of things. It looks at the resource, it looks at the chart, it looks at the live cluster state, and if it understands that, hey, looks like something is getting deleted, I will just go end up deleting those resources. Its primary responsibility is to convert the live state into the desired state of what's written in the Helm chart that has been given to it. That is the source of truth for Helm. So I personally don't think Helm did anything wrong. It doesn't come with any warnings, and that is where this declarative trap sometimes becomes a huge problem in the production environment. So what it tries to do is it will look at the live cluster, it will look at the previous Helm release. All the Helm releases are stored in terms of a secret in the OKE cluster, so it will look at that previous release and then it will look at the new chart. So if it finds that, hey, there was this resource in the previous release, but it is not present in the new release, looks like the user wants to delete that resource. So it just cleans it and it just deletes that resource. This behavior is very intentional and it comes from its state management model. The deletion in this case is a direct it is a direct part of its reconciliation process. It's not a bug. But then the service went down. And here everyone thinks that they are right. The developer who made that mistake, he just said, it worked on my machine, it was fine and running. I don't know what went wrong. The executor who is running this, hey, the deployment succeeded, so I don't think anything went wrong on this part. Everything worked well, the Helm deployment has succeeded, the release has been succeeded, then why is it complaining? And as a deployment service person, when we go and look at the logs, we also see the same thing. Hey, everything is running as what it was supposed to run, but still the service is down, right? So then we started looking further into how we could change it. We came up with a framework which mainly contributed of two things. One of the major component is Helm Diff. Helm Diff is it's an open source plugin which runs during the planning time. It looks at what is the current state of your cluster, what are the proposed changes, and it gives you a preview or a visualization of how it is going to change your cluster once you go and deploy this particular release. It prevents all the unintended modification and the potential disruptions in the production environment. It will help you identify all small mistakes that you can potentially overlook. In this case, for example, when we were looking at the load balancer example, right, it was a simple flip, but if Helm Diff would have been ran before the deployment execution, it would have given that visualization that, hey, this one is going to cause your Helm Diff to get, your load balancer to get deleted. So one of the examples is, this is how Helm Diff works. In this case, let's say one of our customers faced this issue. They ran Helm uninstall for their Grafana releases, and they decided to keep the history. When you enable the keep history flag, it's going to store all the release information that went through before it won't delete those secrets associated with that release. And then they moved on, and then they did Helm install, regular Helm install, but the culprit here is the replace flag. When they used that replace flag, what ended up happening is Helm decided that, hey, looks like this is a new release, I have to treat this as brand new release, and the persistent volume inside it, which had the information of the Grafana dashboard, was lost. It just ended up creating a new PVC and associated it with a new persistent volume. So all the customers lost their important Grafana dashboard related information in this particular case. This is just one example. There have been times namespace has also been deleted. So then the other part of this is identifying which are the critical resources that we could take a look at during the planning time, right before the apply, and understand the impact of what it could create on the production. Load balancer configuration obviously came to our was one of the primary ones, because we have faced more than 17 incidents specifically for load balancer. Then persistent volume claims, because it carries important data information as well. Then we have classified RBAC permissions also as one of the important ones, because if the permissions get modified, it can land up into one of a critical infrastructure incidents. Secrets are other one, network policies obviously, and then the CRDs and resource quotas. So we have classified these many resources as very critical, and mainly the deletion part and the updating part of these ones are classified as critical in our infrastructure. Addition, we do not treat those as something that we need to focus on at this point. Now we have given, in our ecosystem, we have given privilege to all our organization or all our customers who are using this, and they can define their own criticality and their own critical resource level and classify into these 3 categories based on their appetite. So the way this guardrails framework, we have designed a framework specifically for this. So the way it works is, first, when the deployment is getting planned, we run a 3-way Helm Diff. 3-way Helm Diff is important because we want to capture the live state of the cluster, associate it with the previous release, and also look at the new chart at the same time. Helm Diff also works with a 2-way release, but it doesn't query the live cluster state. So we may end up missing critical information if we were to miss out that flag. Once we have that information, we will go through a demo where you can see Helm Diff generates a huge output. Our customers and are releasing, within one release, there are like hundreds of Helm charts getting upgraded, right? So it would be a very daunting task for an SRE to go through each Helm Diff line and figure out if there is anything missing. So we analyze and summarize these Helm Diff and figure out what is important and what needs to be flagged to a particular customer. Then a risk assessment is conducted based on whatever the output and the summary is, to identify if this release needs to be blocked. Should we give warning to our SREs or any deployment executor, and does it qualify for a second level of approval? The second level of approval is obviously with the higher management at that point. This is just to raise awareness that whatever you are doing can lead to a significant production downtime before you proceed, and if it is low risk, then we just let the release go and let it execute. Yeah, as you can imagine, the value for the deployment executor in this particular case is huge. They can perform their release with a very high confidence. They do not have to worry about any repercussions or any production downtime or anything that they haven't visualized could be coming their way. So the entire CI/CD architecture would look something like this. The developer would create a PR with whatever the Helm chart updates that they have. They feed this into their CI pipeline that triggers their PR creation update, the Helm diff runs. Once the Helm diff is running, it generates whatever the changes are there, and then the guardrail framework comes in. It takes all the Helm diff output, it parses it, it summarizes it, and then based on whatever the output is, it will give you an approval or a warning. And this has also helped us in applying few policies at an organization level, at a compliance level. Let's go through a quick demo over here. As you can see, this is just the Helm template that I had deployed earlier. If you can see, there are a bunch of secrets. The password here is, for example, 1234. Then there is a config map on this cluster that we have configured with values. And then there is a PVC also that we are creating as part of this release with the mode read write once. Then we have two services configured in this particular cluster. One is the cluster IP and the other one is the load balancer service. And lastly, we also have an ingress. We have a deployment, also configured Nginx container deployment. And then lastly, we have an ingress configured. Now let's look at, we'll tweak few things and see how will it run in production. This is obviously a minimized demo that I wanted to make. If you see, we have deployed this release. The name of the release is demo. It's for Helm guardrails. If you can see, the cluster is up and running at this point with all the resources deployed onto it. The deployment went through, the cluster IP, load balancer, the config map, the secrets are all running. And now we are modifying it. We are updating PVC condition to be enabled as false. That means we are potentially deleting it. Then we are updating our passwords in this case from 1234 to 5678. And lastly, we are disabling our load balancer service using our values.yaml file. So the next step is we are running the Helm diff. Now, if you can see the Helm diff over here, you see that it is saying that the secret has been modified to a new value. Then it says that there are two primary things that are being removed because we had disabled them. Remember, we disabled two flags. One is for the load balancer and the other one is for the PVC. Now, when we run guardrails through it, it tells us and it warns us towards the end that the load balancer service has been deleted, the persistent volume has been deleted, and the secret has been updated. This gives a very summarized view to the SRE that these are the potential things that are getting deleted, and then based on whether it's an approval or a deletion, it will go through. Helm diff also, right now we have just, in our first phase, we are just doing it for upgrades, but it also comes with, for rollbacks and for uninstalls as well, you can run the same command and capture the output to safeguard the resources that you want to on the production. Yeah, as a result of which we have particularly seen a lot of decrease in our SEV1 and SEV2 and less deletions after we have adopted this particular framework. And yes, we are no more going blind when we are doing deployment. We are just trying to raise awareness at the deployment planning level rather than at the execution level to our SREs or whosoever goes through our deployment service. It has restored a lot of confidence with the SREs who are executing using this particular framework. Yeah, that's all from my side. Thank you, everyone.